Imagine being able to put in a Rust crate and it sets up an entire development environment for building out Stellar smart contracts, then integrating that with a pre-built boilerplate for the front end. That's the goal of Scaffold Stellar, a project by AHA Labs. Let's dive in and take a look. So all the code for this is of course open source. This is on AHA Labs GitHub repository, Scaffold Stellar. You can scroll down and there's a little bit of information about what the project consists of. There's the Stellar Scaffold client, the main command line interface for Scaffold Stellar. It provides commands for initializing projects, managing development workflows, and automating contract deployment. Then there's the Stellar Registry CLI, a CLI tool for managing on-chain contract registry, handling contract publishing, deployment, and version management. Stellar Build, the core build utilities and helper functions for Stellar smart contract development. Stellar Scaffold Macro, a Rust procedural macros that simplify contract development and integrate with the Scaffold Stellar ecosystem. And then there's a registry, the on-chain smart contract that powers the Scaffold Stellar registry system, enabling contract verification, naming, and version management. So the two main files here are Stellar Scaffold and Stellar Registry. I'm mainly looking at Stellar Scaffold today. And this is the boilerplate, if you like, which creates a hello world contract and kind of token interfaces. And it also kind of creates the front end, which has all the kind of wallet integrations already pre-built in. If we go down to quick start, we've got some instructions here, and I'm going to open up Windows Subsystem for Linux. Whenever doing anything in Rust, I always prefer to use Linux rather than Windows. Apparently Mac is also getting a native container system for Linux. That was announced at Apple's Worldwide Developer Conference last week. So the first thing we're going to do is run cargo install Stellar Scaffold CLI. I already have this installed here, obviously, but if it's the first time using it, then it will run through a list of dependencies and take a couple of minutes to install. From there, we can set up a project. So let's go Stellar Scaffold init, and let's call it my project. We can then move into that folder. You can see this is our kind of directory structure. Let's clear this. If I run lsal, we can see we've got this .env hidden file, .env example. What I want to do is I want to edit this and save it as .env files. So let's move it first, .env. .example to .env. And I'm going to use Nano to go in and edit it. Nano is like a command line text editor. So currently this is set up to use a local network. I don't want to use that. I want to use a testnet. So I'm going to change this to testnet. I need to change the network passphrase, which I remember is 2015, but I can never remember what it exactly is. So I'm going to copy this URL. And it is this one here, the testnet network passphrase, September 2015. Let's go up and paste that in. And then for the RPC node, I'm going to use the one that they provide as well, which should be HTTPS. And that is this Stellar RPC here, Soroban testnet stellar.org. Let's remove the white space, and then we're going to Control X to exit it, save it as .env file. So now if we read the .env file, we can see we've got the testnet set up. Obviously, we wanted to deploy this to mainnet or production environment. You change them settings to the mainnet settings in this network document here. Now if I go into contracts, we can see we've got a fungible token interface and a hello world contract. Let's have a look at hello world. You've got a very basic hello world smart contract here, which can act as a starting point for you to start writing Stellar Soroban smart contracts. We come back and run npm install. We're going to be using Node.js to set up the front end. So npm is the dependency manager for Node.js, which is like a JavaScript runtime environment. And once that's all installed, we can run npm run dev. And let's have a look, see what we've got running on port 5173. What we've got opened up. And there we go, we've got our basic boilerplate front end here, which is already connected to the testnet. We've got this button to connect Freighter. So I haven't got Freighter wallet on this browser. Let's open up Brave and copy this URL in for localhost. So this is running locally on that. It's kind of using that Windows subsystem for Linux container as a server, almost a web server, which is open up this port 5173. Because I have a Freighter wallet, which is like a browser plugin installed on this browser, I can connect that to the front end and it's displaying my wallet balance. Unfortunately, I think this is just testnet funds. And there's my wallet address and it's saying that we're connected to testnet. From here, there's some instructions about what you can do once you've got this up and running. So the first is you can run Stellar Scaffold Watch. This is quite exciting. It means you can actually kind of edit your smart contracts in real time and it will compile them automatically. Almost like a React site will kind of update any changes automatically. As soon as you change that smart contract and save the file, it will kind of notice that's been changed and then recompile them and deploy them and set up all the kind of the contract interfaces so that you can use them directly here. To make all that work, you import the contract like this into the front end. This is already done for us, obviously, in this example. And then we can call like smart contract functions directly from the front end just by calling these async await functions. So this is the name of the contract, which we set up here. And this is the name of the function. We're passed in the to variable as world. And if we go back to our smart contract, you can see we've got this public function here, which is what's getting called. And that's passing through the environmental variable, which we don't actually pass through when we're calling the function from the front end, and a string for the to variable, which directly matches this function here. The final thing it notes is that the project is already integrated with Stellar Wallet CLI. That's what's being used here to kind of create a wallet interface so that you can interact with smart contracts directly, or your users can interact with smart contracts directly using their own wallet keys. And finally, some instructions on once you want to deploy your site and the contracts to production, you can use Stellar contract to deploy, and then npm run build to build out a distribution directory, which we then upload to a web server or use some kind of cloud interface to host that remotely and then link a domain name to it. If you're interested in building decentralized applications, then Scaffold Stellar is a great starting point. It's got everything you need from the Rust-based smart contracts and these simple examples, which are directly linked through to this front end, which is set up for a development environment. You can get live changes on that. So you can see when you make changes to the smart contract and the front end code, that's all updated in real time. All the wallet integrations are done for you, so you can focus on your business logic and building out real Web3 applications. Hope you enjoyed this video. If you want to learn more about building on Scaffold Stellar, there's a link to a tutorial and a bunch of developer resources in the description. Thank you for watching.